Welcome to Lecture 8, Dynamic Modeling. It's about modeling actions and the interactions of objects for conceptual modeling. This figure shows the context of dynamic modeling in the development process. This is the last activity of analysis phase. We have done structural modeling and obtained the entity classes with their relationships in previous lecture. In this lecture, we further model actions and the interactions of objects to satisfy the behavior requirements of a system. This lecture covers three major topics. The first topic is a concept of dynamic modeling. You will understand what is the purpose of dynamic modeling, why do we need dynamic modeling, and what are the features of dynamic modeling. We also need to know what are the building blocks of dynamic modeling, and what is the relationship with behavior and structural models. The second topic is to understand the context of objects' interactions, know where to look at them, how to model object actions, and analyze the changes that have significant consequence for the correct operations of the system. Dynamic modeling is about objects, their interactions, and how the objects change through interactions. The third topic is to learn 4 types of dynamic diagrams, including sequence diagrams, collaboration diagrams, state chart diagrams, and activity diagrams. This figure depicts the process of developing dynamic modeling. It demonstrates the relationship between dynamic modeling, behavioral modeling, and structural modeling. Dynamic modeling adds a new perspective to analysis. Behavioral modeling tells us what system is required to do, that is, behavior. And structural modeling identifies what elements of a system and their relationships, that's the structure. Dynamic modeling is used to verify that components of a structure can satisfy the behavior. Dynamic modeling represents how the structure of a system and its components act and interact to satisfy its behavior requirements. Dynamic modeling is concerned with actual objects. Please notice that the building blocks of the dynamic modeling are objects. Dynamic modeling is about objects, their interactions, and how the objects change their states through interaction. Objects have lifetime. Their interactions happen in time and follow the logical order. The objects are collaborated together through message exchanges. Objects must collaborate. Collaboration requires that objects are organized with specific capabilities and individual responsibilities. Therefore, dynamic modeling must show not only who interacts with whom and how, also in what order. Dynamic modeling is working on the 2 dimensions environment, namely the time and the space. Dynamic modeling represents structure in motion, spatial, and temporal. However, adding a timeline to a mixture of behavioral and structural models would not mechanically yield a dynamic model. Please make sure to understand this figure to explain the dynamic modeling. This is the major task of this lecture. The dynamic model is a collection of multiple behavior diagrams, such as sequence diagram, collaboration diagram, state chart diagram, and activity diagram. Usually, at least one diagram regarding each class with important dynamic behavior. Those diagrams are used to understand behavioral requirements, detect and supply methods for the object model. Sequence diagram is to examine the orders of interactions of objects in time. It models the object interactions by message exchange. Collaboration diagram is similar to sequence diagram but in different viewpoint. It focuses on how the objects are organized and what set of messages they must exchange to satisfy a certain behavior. State chart diagram is used to model one object to trace the result of interactions on the states of objects belonging to a specific class. Activity diagram is used to describe the logical flow of activities. A sequence diagram is composed of a timeline, objects, and actors that interact across the timeline, and the message that they exchange. Sequence diagram represents the interaction between the objects or between actor and objects ordered in time. Sequence diagram axis. The vertical axis is a timeline or a chronology of events. The horizontal axis identifies the space and the actions that take place among objects. We draw a sequence diagram for every use case. This is an example of a sequence diagram for use case make appointment. It's based on the text of the use case scenario. We map the use case flows to the message onto the sequence diagram. The text and the message arrows indicate the calling and the return. The potential objects are identified. Each object is at top of a column. The column represents object lifetime. You should be able to create sequence diagram for a use case. Collaboration diagram is a dynamic diagram that focuses on the organization of objects that must cooperate by exchanging messages to satisfy a certain behavior. The best way to arrive at a collaboration diagram is to start from a sequence diagram. Sequence diagram and collaboration diagram are very close and differ only on the point of emphasis. Sequence diagram and collaboration diagram are very close and differ only on the point of emphasis. Sequence diagram focuses on the flows of interaction, while collaboration diagram focuses on the organization and structure. State chart diagram represents milestones in the lifetime of an object when its state changes. A state is an object's condition at a certain stage and from a certain viewpoint. It's a snapshot of the object in an important point in time. state chart diagram consists of the states of an object and the flow of events that change its state. Some of objects may not have significant milestone to describe. Activity diagram provides the most lucid tool for modeling the logic flow of activities that take place between the system and the outside world or within the system among its components. Activity diagram is concerned with the logical flow of activities in a most pure form. It is done during the behavior modeling in previous lecture. It's used as a needed basis. The deliverables are sequence diagram, collaboration diagram, state chart diagram, and activity diagrams. With the aforementioned objectives and the key points of this lecture, you need to further studies on readings and practice. You need to read lecture notes to achieve the required objectives in this lecture. You complete the quiz questions in order to get 2 marks for this week. The result of this lecture comes from Chapter 9 of the textbook. Lecture notes and review questions are available on LMS. Completing the task of each week is a key to succeed this subject. Please make sure to finish the learning activities each week. You may email your lecturer for consultations if you have any questions.